This should help get you started with homework 1 for BAS 320. So here I've downloaded the homework1.rmd file to my BAS 320 folder, along with the other files, the Excel file, and also homework1-ops.dat. So the first thing you want to do after loading up the RMD file is making sure to change the title so that your name is actually on it. So I'm going to change this to Adam Petrie. And if you're in the Monday, Wednesday section, you can leave that as is. If you're on Tuesday, Thursday, go ahead and put TR section so that we can keep you guys separate. This is a reminder of the due date. You don't need to change anything. And also make sure you do not change the first R chunk. This is just to help display the output of R a bit better in the document you're going to compile. So, all right, just as a reminder for how to work with some of this stuff in R, let's work through the first part of question 1. So question 1 is just like question 1 in the activity that we worked through, where we want to define a variable x to be 2 and to translate an expression into R so it can be evaluated. Now, the equation looks really funny in this form. It turns out if you want to have equations display in HTML or Word this way, you have to write it this way. So I'm actually going to go ahead and just click knit HTML so that I can see what these equations are actually supposed to be. Okay, so there's that first equation. I'm just going to move that over here. And the first part says that we need to define the variable x to be equal to 2 because x actually appears in these expressions. So what I'm going to do is I'm going to modify the chunk of our code to accomplish that and then to also evaluate the expression. So an R chunk starts out with 3 back quotes followed by our curly brace with some options in the middle, and then ends with another 3 back quotes. And you're going to leave any of the lines that have the back quotes as is. Don't mess with those. What you are going to do is you're going to delete the hashtag replaced with your R code and put in the R code that is required for the assignment. So the first part, defining a variable x to be 2, I can use the left-hand arrow convention to write out that command. That's the name of what I'm about to define. The left arrow does the defining, and 2 is what it's going to be defined as. So I can just have my cursor on that line and click Run, and I see that now in the environment R knows that the variable x is equal to 2, so if it sees an x again, it's just going to automatically substitute 2 into that expression. So, all right, here we have our expression 0.5 times 9 minus 3 plus 3 squared times 6 over the quantity 2x plus 3. Let's put that into R. All right, so this first chunk is 0.5 times 9 minus 3. Now, one of the things you have to be careful about is that R needs to be made aware of any implicit multiplication symbols. So when we look at this, we know that this means 0.5 times 6, but R actually needs to have that multiplication symbol that's been suppressed in the writing of this expression. So I actually need to do 0.5 times 9 minus 3. So I'll go ahead and just make sure that evaluates correctly. It does. If I left out that multiplication symbol, I would have gotten an error here. So making sure that multiplication symbol is there is important. And then let's go ahead and finish off the second chunk. So 3 squared, we know is 3 caret 2. That shift 6 produces this caret. And this is going to be multiplied by 6 over the quantity 2 times x plus 3. So 6 divided by, and so since there is more than one number in the denominator, I need to put parentheses around the denominator, 2x plus 3. Now, I've written this command incorrectly right now just to show you that it's going to evaluate incorrectly. In fact, R is anticipating that, hey, this isn't going to work. So if I were to run this, it says, hey, unexpected symbol. All right, not very informative. What happened? Well, I forgot to put the implicit multiplication symbol between the 2 and the x. So as people, we can read 2x easily. We know that means 2 times x, but R needs to explicitly be told, hey, you're multiplying 2 and x together. Notice now that x goes away and it evaluates to what I would anticipate. Okay, so for the remainder of the problems in part 1, you'll just leave the lines with the back quotes as is and replace the hashtag, replace with the R code, with the relevant commands in order to produce the expressions. So I'm going to skip the rest of that stuff and talk a little bit about question 2. And here I'm going to have you convert an Excel file into a spreadsheet that R can actually read. So right now, the data is contained in homework1-clickthrough.xls. So I'm going to open that file in Excel. And the way to get an Excel document into R easily is actually just to save the document as a .csv file, a comma delimited file. So on a Mac, and the procedure is similar to a PC, you would go to File and Save As. And in the format, you're going to choose .csv. You might have to search around in this list of options if you're on a Windows, but you're looking for the .csv here. So I'm going to save this into my BAS320 folder. I've already done this, so it's warning me, hey, do I want to replace it? Sure, that's fine. And I'm done with this, so I can close this out. And the first part is, of course, I need to read in this data frame. So this first chunk of our code says, hey, note to self, remove this eval equals false on the line above only after you've created the .csv file. So the reason why this is occurring, and this is really the only time this will appear in the class, is that in the chunk options, anything after the comma with this R here, tells R how to handle the code in the R chunk. And eval equals false says, hey, don't actually run this code and don't put the results in the document. Why did I put eval equals false here? Well, it's because unless you had already made the homework1-clickthrough.csv file, if R tries to run this, it's not going to find that file, it's going to crash, and it's not going to actually compile the document. So now that I have that .csv file, I can go ahead and just remove the eval equals false and remove that comment here. I can click this or run this to make sure that yes, indeed, it does work. All right, so it's in there, and I can say, okay, how many rows and columns are in the data frame? Well, I know immediately just by looking over here that there's 13,594 rows and 15 columns. But there's actually some R code that will give me the answers to that. The relevant commands are nrow with the argument of the data frame and ncol with the argument of the data frame. That tells me the number of rows and columns, respectively. And you notice that when I'm asking you to actually write something, I have a line that says response. Feel free to write your response in that blank. So 13,594 rows and 15 columns. Okay, so you can replace the rest of these hashtags with the relevant R code here. And one thing that I did want to talk about was part F here. Nope, I didn't want to talk about part F. I actually wanted to move on to question 3, where we deal with online product sales, and specifically the way the figures are presented. So in part A, I say, hey, make a histogram of the values in outcome M1 and another of the logarithm of the values. And specifically in the R code, I want you to separate those commands by a semicolon so that the plots appear side by side. Okay, so let's go ahead and read in that file, run that line. And there it is in the Environment tab. And I know that to make a histogram, the command is just hist, and I need to refer to the column of values that I want to make the histogram for. So the name of the data frame is OPS, and then if I put a $, that's going to extract a particular column. And one thing I like about RStudio is it actually gives you a list of all the columns in that data frame. This is a huge data set. In this case, I'm just going to click outcome M1. You can feel free to type that. And then what I'm going to do is I'm going to move on and make that second histogram, with the exception that instead of the values themselves, I'm going to do the histogram of the log base 10s of the values. So if I just highlight this first part right here, that'll give me the histogram of the original values. If I highlight this part over here and run it, that gives me a histogram of the logarithms. If I just have my cursor on the line, it'll evaluate the entire line. I'll click run and you'll notice that, hey, it doesn't look like you actually put the plot side by side. The reason why is because it actually doesn't. The only time it will appear side by side is in the knitted HTML or the knitted Word document. R will only produce one plot at a time, but of course I can cycle through those by clicking the arrow here to look at all the plots that have been produced in the current session. So just to see that, I'm going to go ahead and click knit HTML. And since it compiled, I know that all my code is running correctly. If you do get a compiling failure, that probably means that some of your R code is incorrect. So go through line by line and make sure that each line of the R code runs. And once that happens, the document should compile just fine. If it still doesn't, you might have messed with some of the back quotes. Make sure that you always preface your R code with those 3 back quotes and some curly brace action, and end with 3 back quotes as well. All right, so here's what the output is going to look like here. And if we scroll down, we see that indeed these 2 plots do appear side by side in the document, whereas they didn't actually in RStudio itself. So if I open this in a browser, then I could go ahead and do File and Print and save this as a PDF if I'm in a Mac. The procedure for Windows machines is slightly different, but not too bad. And if possible, actually, it's probably better to knit this as a Word document, because then you can actually format some of the resulting document. With HTML, you're stuck with what it's been compiled to. But in a Word document, I could go ahead and actually create more spaces between things. Here, it actually looks like I have failed to get the pictures on the same line. So that's a little bit disconcerting. I'm wondering why that's the case. Here's some live action troubleshooting. So notice after the R there's a comma and then some extra comments. Fig width and fig height actually dictates the size of the figures in the output. So if I change that from 4 to 2, my hunch is that it will make these figures smaller. Let's see if that works. And it did, but it made these graphs look ridiculously small. In fact, you can't even see really what's going on here. But that is a way to get the plots on one line, I guess, in Word, unless you want to move around those pictures manually. So I guess I'll be okay with either way that you do it. If you happen to have watched this and know the trick to make the files appear, or the figures appear on one line, you can use that, or you can manually resize these as well. Not the most glamorous option. It was supposed to be easy and automatic, but there we go. You can automatically resize them so they're on the same line there. And I do think that that is the last thing that I wanted to talk about. So hopefully that's helped you out get started with homework number 1. We will have office hours on Monday and Tuesday. So those will be posted on Blackboard. Check out the contact section for the TAs in my office hour. And we'll see you then. Just make sure to have that turned in by 3:30 on Tuesday, either in class or to my office or to my mailbox.